I'm Ahmed Daud, and in this session, we will carry out the last discussion that we are doing in the case of pre-pruning. We were doing the case study in which we have to build such type of classifier which can predict or classify that what type of person will default in future or not. So that bank will save the bank and use that particular classifier to enhance their power of taking decision either to approve the loan or not. Okay, that problem we were discussing in the last time when uh, we are discussing about the pre-pruning, and we have built a lot of models, pre-pruned models. We have actually put some restrictions on the growth of algorithm or on the algorithm so that we can build such type of model which will not lead to overfitting. Okay, so we have used the grid search approach to find out the best hyperparameter values. So in this session, I am going to use the same case study, and now we will try to apply the post-pruning approach, and we will see if we will build a decision tree by using post-pruning approach, what type of scores we will get. Okay, so in the start, we have figured out that recall is the our best score. This was our data set, and these are the about a lot of variables are categorical. Then we have converted our categorical columns into some numerical form according to ordinal and nominal way. After that, we have all the variables in the numerical form. Then we have split it into x and y, and then train and test split. First, we have created a default model, means a model with a default hyperparameter values, when it means that there is no restriction on the algorithm. It can build the decision tree, uh, and you can say with any without any restriction, and that type of decision tree can lead to what's the overfitting when there is no restriction on the growth of decision tree. Okay, so we have seen that the recall score was 100%, but recall on the testing dataset was very low, which was just a 40%. In the case of accuracy again 100%, but on the test dataset it was just a 63. So it is quite clear that our model or our decision tree here with default hyperparameter values is overfitted. So here I am going to create a data frame in which I can store my scores of accuracy with respect to training dataset, accuracy with respect to test dataset, recall with respect to training dataset, and recall with respect to test dataset. And at the index, I will write some name so that I can compare the models with other models, what model are giving which type of score good. Okay, so in other words, you can say to keep the track of the scores, I am creating this data frame. Okay, so this was the confusion matrix, and then we have seen that our model with default hyperparameter values, it's quite complex. A lot of you can say 187 leaves and 18 depth it has. So then we have performed pre-pruning, but first we have analyzed the hyperparameters that are actually responsible for the restriction of the algorithm, or you can say restriction of the growth of tree. So when we have put the max leaf nodes is equal to 40, we are getting this type of recall scores, and then we have seen regarding mean sample leaf, and in that way we have seen against multiple hyperparameter values individually. Then we went towards the part of hyperparameter tuning, and we have here going to use grid search CV. So before that, we have to define some ranges of the values for each parameter so that we can select the good hyper combination of hyperparameter values. And keep in mind, as I told you previously, like some hyperparameters are responsible for the restriction of the growth, but some are not. Like criteria, actually not it cannot restrict the growth of the tree. It just responsible for that which type of performance measure or impurity measure the algorithm should use. Okay, and in the same way the class weight is also just to balance the data set. If we have data set in which, like here, we have a lot of samples belonging to a zero class but less samples belonging to one class, so our data set is actually imbalanced. So if we want to make it balanced, we can pass this value to the class weight, and but it is not responsible for the to put some restriction on the growth of the tree. Okay, so according to grid search CV and according to the recall as our performance measure, if we have defined here, yes, recall as our scoring. So we got these hyperparameters values are the best values. We have trained a model on these hyperparameter values that we have find out from grid approach, and this score we got here 0.56 on training data set accuracy, and in this way we are getting this type of score, and I am going to add these scores in my data frame to keep the track so that I can compare. Here we can see that score on the testing data set recall score is increased in case of that pre-pruned decision tree, but our accuracy score on the test data set is a decrease in the case of that pre-pruned decision tree that we have built with respect to the recall. Okay, so here I have decreased the depth because previously I have seen that my decision tree with the depth is equal to 4. It is not making the sense because at each side on the left and right side the further splitting of the node are not splitting or are not distinguishing between the classes. So with the depth one we are getting the same type of score. Okay, like on the left side all sample belonging to that will go on the left side will be belong to class 0, and all the sample belonging will go towards the right side will belong to class 1. Okay, this is actually the recap of the previous session. Then we will start our today's post pruning session. So quite simple tree. Then we have built a decision tree, pre-pruned decision tree with respect to the accuracy. And when we have passed the accuracy as our scoring, we have seen that these are the best hyperparameter values. And again, you have seen that balanced class weight is equal to balance is selected in that case, the best hyperparameter value for the class weight. And in the previous case, with respect to recall, again, we have selected balanced best value for the class weight. It means like first if we will do convert our imbalanced data set into balanced form, then our score will be better compared to the imbalanced data set directly used. Okay, so here we have built a decision tree with respect to the pre-pruned decision tree with respect to the you can say accuracy, and we got this type of score. So this was not giving some good results because here we can see that in the case of pre-pruned decision tree with respect to accuracy, our score that we are getting on the testing data set accuracy score 0.6, it is less than compared to the default model. So this model is not giving some good results, even though it is bad than the default model also. Okay, so now we are going towards the part of post pruning, and again we will start from the model which is with the default hyperparameter values that you can see here, very complex model. So like always in the previous session you have seen, first we have to create the instance of the decision tree classifier, then we have to use the cost complexity pruning path to get the possible values of alphas, and then we are getting here for the alpha values. Here I have created a data frame of alpha and impurities. So there are 86 possible values of alphas are present, and last value will be for the will contain the, if we will pass 0.016 in the decision tree, it will have just one root node. Okay, so total 85 you can say the possible values that we can use to analyze the test data set. Okay, so here I am going to build a classifiers list so that I will train a classifier, or you can say decision tree, one by one with respect to each alpha value, and I will train that, and then after training I will append in that list. Okay, so here you can also see the number of nodes in the last tree are just one, so I am going to remove that from my list of alphas and from my list of classifiers. So now I am going to build a train scores list and test scores list uh, for each classifier present in my list. Okay, for classifier in full list of classifiers, and then I am checking their accuracies on the train dataset and on the test dataset. And here I am also plotting the graph on the like you can see, as alpha is growing, my score on test data set, which is representing here by orange line, is increasing. Okay, and after some particular alpha value, it becomes you can say stable, it is not further increasing. But here you can see our overfitting is increasing in that case, like when our alpha is increasing, as our model becoming simpler, our accuracy on test dataset is increasing, but on the trained dataset is decreasing. But this is our first, you can say, aim to have some good score on the test dataset, because whenever we have to deploy the model, we want such type of model which can correctly classify new or new data points that it has not seen during the training part. So here score is increasing on the uh, accuracy is increasing on the testing data set, we can see from the graph also. So according to the test scores, I am getting the uh, index, at which index my score is maximum on the test data set, accuracy score, and then I am going to see that which classifier has produced that maximum score, and this is the best model. So decision tree classifier with the alpha value 0.004 is the is giving the best accuracy compared to all other classifiers, or with respect to different alpha values, and this is present at the index number 78. Okay, so the classifier that I have obtained here, which is this one, is giving the accuracy 74 on training data set and 71 on the test data set, and this is giving 78% recall on the test training data set, and just 50% on the test data set. So I am again going to append that scores in my data frame. So here you can see that this post-prone decision tree with respect to accuracy that I have built recently, it is giving me the highest accuracy on the test data set comparing to all other previous models that I have in the case of pre-pruned and in the case of default model. 0.71 means 71% accuracy. Because it has built with respect to the accuracy, so I am not going to here compare with respect to recall. And in the case of recall, it is not giving good score, but with respect to accuracy, it is quite good, because I have here extracted the post-prune decision tree with respect to recall, because the default score parameter, score method, calculate accuracy. So now again, I will go towards the this is the decision tree that post-prune decision tree that I have obtained, which is present at the index number 78, or you can say at the index number 78. Here you can see this alpha value 0.004. This is giving uh, the decision tree that will be built on that alpha value, will give the best accuracy score on the test dataset compared to all other decision trees that can be built on the other alpha values. Okay, so this type of structure that particular post-prune decision tree have. Now I am going to build a decision tree, or get the post-prune decision tree, or the alpha value of with respect to best recall. So now I am going to create two lists, recalls on the training data set and recalls on the test data set, against each classifier that are present in the my classifiers list. So here I am going to use a recall score, and if I will analyze my graph, you can see as alpha is increasing, my recall score on test dataset is not much increasing. It is fluctuating at some certain position, and then after certain value of alpha, it keep on decreasing. And we can see that in that case, if we will find out the post-prone decision tree, or with respect to recall, we will not get some good, or you can say some extraordinary decision tree. Okay, and we can also check here. So I am going to find here index at which my recall on the test dataset is maximum. So after getting the index, I am going to see which model is present at particular index. Then I am going to see that model and their index. So here the decision tree classifier with the alpha value 0.0011 at the index is equal to 4 is giving the best, or you can say highest recall score compared to all other decision trees, or you can say compared to all other decision tree with respect to other alpha values other than that 0011. Okay, so this particular decision tree is giving highest recall score out of R. So we can see what the highest score it is giving. It is just giving 0.41, which is not quite good. Okay, so again, I am going to append the score of that post-prune decision tree with respect to recall, and here I have appended that it is giving a very highest score on the training data sets in the case of accuracy and in the case of recall both. But on the case of test data set, it is not you can say generalizing well. Okay, because here you can see it is giving just 41% recall on the test data set, which is not satisfiable. So what I will do now, here you can see this is the post-prune decision tree with respect to recall I have obtained, and it's again quite complex. And from the scores, you can also get an idea that this post-prune decision tree is still overfitted. So what I am going to do the next, now I am going to put some values in the hyperparameters that are not actually responsible for the restriction on the growth of decision tree. Okay, like criteria is equal entropy we have find out in the case of pre-pruning, or in the case of when we have run the decision grid search approach. We have seen that criterion is equal to entropy, class weight is equal to balance. These are the best values. Okay, and these values are not actually put the restriction on the growth of tree. Balanced means you are changing your imbalanced data set into some balanced form by giving some weights to the zero sample and one samples. And criterion is equal to entropy means you are here specifying that entropy impurity Murray should use for the splitting of the node. Okay, but this value by default its mean weight fraction is equal to 0 in the case of when you can see the documentation. But as if I will pass the class weight is equal to balance, it will give some weight to each sample. So instead of uh, again calculating the min sample leaf, okay, I am here saying that I as I have given some weight to each sample, so I should measure the mean weight fraction leaf, because weight fraction leaf can measure the weight of the samples, and that I have given by specifying the balance value to the class weight. So by default it's 0, so it's 0, it will not make sense. So I am going to give the value 1 over 700 to that particular hyper parameter, so that it will work same like that mean sample leaf, so that it will not put a restriction like the pre-pruning do. Okay, so 1 over 700, when we will pass 700 training samples to data set, and 1 over 700 weighted fraction multiply with the 700 that we will pass the samples, we will get 1. Okay, it means that one weighted fraction should be at each leaf node when doing splitting. Okay, to make it similar to the to make the working of that hyperparameter similar to the mean sample leaf. Okay, so keep in mind here it will not put any type of restriction on the growth of algorithm, but it will change the structure of the model, because here I have instead of imbalanced data set I am going to pass balanced data set. So now I am passing I am creating the instance with respect to the criterion entropy, class weight balanced, mean weight fraction leaf 1 over 700. After building this type of model, again now I am going to use the post pruning approach. It means I will build a whole decision tree with respect to that balanced data set, and then my decision tree will be pruned with respect to minimal alpha, and I will get different values of or you can say some different value of alphas and impurities. Okay, and you can see that I am creating a data frame with sorry, a decision tree. I am going to do post pruning on the decision tree, on in which we will pass some balanced data set, and in which we are going to use the criterion entropy. So keep in mind this will not restrict the growth of tree like pre pruning. Okay, it is just changing the structure. So here, as it is example of post pruning, so we'll do post pruning here. So I am going to do use the cost complexity pruning path, and again I will get some values in the alphas and impurity values. So again I will create here different decision tree classifiers, with different alpha values that I have find out from the post complexity pruning path. And I am going to save all the classifiers after training into the classifiers tool list. Okay, now all the classifiers you can see in that list will have class weight balanced, criteria entropy, mean weighted fraction 0.0014 equal to 1 over 700, and weight sorry, alpha value will be different in each case. Like in the first case alpha value will be 0, in the case of second alpha value will be like here 1.4, then 1.49 and something, and then 2.9. Here you can see the alpha values are different. Okay, and you can see that at the start it is 1.4, and here the 10 raised to power minus 18 means it is not the 1 point, it is 0 point, a lot of zeros and then the 1. Okay, very small value of alpha. So here we have obtained a lot of alpha values. Now like last as always we know, last uh, alpha value is corresponding to the decision tree with just one node, so I am going to remove that. And now I am have a classifiers list in which there will be not alpha value of corresponding to single node decision tree present. And this is the classifier that like the classifier of just one node is removed because I have specified here the range, and here the alpha range also have not that particular alpha value corresponding to the you can say corresponding to just a single node decision tree. Okay, this one we can say like a 0.03, uh, the alpha value is not in that list, and the decision tree which will be built on that 0.03 alpha value will also be I have removed from here. So now I am going to find out the classifier, post pruning classifier with respect to the recall score. Okay, I am going to create two lists: training recall scores on the training data set and recall score on the test data set against each classifier that are present in my classifiers tool list. Here we can see that the best score on test dataset, recall score on the test dataset is giving by the model that is present at the index number 70, and it is giving 68% score on the recall score on the test dataset. And now if we will see on the training dataset, it is giving 92% score. This post-pruned model is giving 57% accuracy on the training dataset and 47% accuracy on the test dataset. If we will pass that post-prune, like append the scores of that model in the data frame, we can compare here easily. Like post-prune decision tree, balanced decision tree with respect to the recall we have obtained here. With respect to recall, so we should compare the recall score on test dataset. It is 0.68, which is highest compared to all other decision trees that we have built till now. All other decision trees like pre-prune decision trees, post-prune decision trees in which there is no balanced dataset. So this is when we have made our dataset balanced, or by specifying the hyperparameter value class weight is equal to balanced. Then we and making using another impurity measure which is entropy, and we are getting good score compared to previous models. And how we have figured out that balanced data balance value we should use or entropy we should use, we have seen in the grid search approach we always getting balance against the class weight and entropy against the criterion as a good hyperparameter values. Okay, so this particular model is that we have selected here, best post pruned decision tree with respect to recall. This has all these values. So if you want to analyze this structure of that decision tree, you can see from here clearly. Okay, so again, these are the scores. Okay, so you can also find out post-prune decision tree with balanced data set with respect to accuracy. Just you have to here, like I have found, find out with respect to recall score. You can here create two lists with respect to the accuracy score and find out the index that is giving best accuracy on the test data set, and at particular index the model or the classifier is present in that list will be your best post-prone decision tree with balanced data set with respect to accuracy. Okay, you can play with that. So as keep in mind these hyperparameter values that I have explained in the post pruning part, these are not responsible for the pre pruning. These are responsible for some other purposes. Okay, so till now you have seen that how we can carry out the process of post pruning. First, we have to build the full tree. Then we have to prune the tree with respect to different, with respect to minimal alpha values. And if we will use the cost complexity pruning path by sklearn, it will give the whole decision, whole cost complexity pruning path. It will return in the form of alpha values and impurity values, and then we can build a decision tree against each alpha value, and we can train on the some data set that we are having, and we can get the decision tree against each alpha value, and then we can test each decision tree on the testing data set, and we can evaluate which is performing well in our case, and that is performing well in our case will be our best post prune decision tree. Like here I have selected this one. Okay, so I hope you got a clear idea about the post pruning process. So in the next session, we will do some further discussion on the decision tree. So for now,